All right, you guys, so continuing where we left off. So we're going to look at a problem that's a little bit different. So we're going to look at y equals 3 times 1/2 to the x power, okay? And we're going to start the same way. We're just going to graph the same points. So we're going to start with 0, and if we plug 0 in for x, let's look at that. 3 times 1/2 to the 0 power. Well, we know we do the exponent first. And so we know that anything to the 0 power equals 1. So now we have 3 times 1, which we know equals 3. Okay? Now, if we plug in our 1 here for our exponent, so we have 3 times 1/2 to the first power. Well, we know anything to the first power is just itself. So now we still have 3 times 1/2. So 1/2 times 3 is just going to be 3 over 2. Okay, and then if we take it to the second power, so we have 3 times 1/2 to the second power. Let's look at that exponent. Remember, this is squared, so you're going to have 1 times 1 over 2 times 2 because you're squaring it. So it'll be 1 over 4, and then we're going to take it times the 3, so it'll be 3 over 4. That's 3/4. Then if we took it to the third power, we're going to say, okay, 1/2 to the third power, we know that's 1 times 1 times 1 over 2 times 2 times 2, and that we said we know that's 1/8, right? But then we're going to take it times 3, so now we get 3 over 8, right? We get 3 over 8. Hope that made sense. So let's go ahead and graph these points, but before we do that, let's change these fractions into decimals, or you can change them into mixed numbers so it's easier to graph. So 3 divided by 2. Well, 3/2, if we want to divide this, we would take 2 divided by 3. Hopefully you remember how to do this. And we know that goes 1 time. So we know that's going to be 1.5, right? So that's easier to graph, 1.5. Let's look at 3 over 4. Well, if we took 4 and we divided it into 3, right, we're going to get 0.75, right? And same thing here, 3 divided by 8. 8 goes into 3. We're going to get 3 here. And so we're going to get, right, and then we're going to get, right, so it's going to be 3.375. I just want you to understand how to change things so it's easier to graph. All right, so here's 0, 3, 1, 2, 3. So now we have 1 and going up to 1.5, so that's going to be right here. And then we're going to go to 2 and 0.75, so we know we're going to go like right here. And then let's say 3 and 3.375. 0.375 is going to be way down here, right? And now let's get another point on our negative side. So let's just plug in -1 for our exponents. Let's go back up here and say, well, 3 1/2 to the -1 power. So let's do that quickly. So if we know, remember, this is going to flip. This exponent's going to flip. So now we're going to get 1 over 1/2, right? And then if we multiply it by 3, we're going to get, we're just going to basically say, so now let's take our 1. So now we're going to say 3 times 1 is 3, and we're basically going to flip this. So we're going to put the 2 up here, so it's going to be 3 times 2, and we're going to get equals 6. Hopefully you remember what I'm saying, how to do that. All right, so if we're at -1, we're going to go up to 6. 1, 2, 3, 4, 5, 6. So now let's look at this graph. So let's go ahead and plot our points now. Okay, and so we're plotting these points. And if you notice, this graph is going down. It's rapidly decreasing. So this is called exponential decay. This is called decay. So basically that's a science term when something rapidly declines or decays. So let's kind of think about this for a second, because this is going to help you when you're graphing with your homework. All right, so we're looking up at the original problem, and we look at the number that's inside the parenthesis. If it's less than 1, then it's a decay. Okay, so if we have less than 1 inside that parentheses, then we know it's a decay. If it's greater than 1, then we know it's growth. So the last one that we did, the last video, we knew that was exponential growth. This is exponential decay. So it's declining. So I want to make sure that makes sense. So let's talk about growth and decay for just a second. Let's think about that for just a second. So whenever you have a graph that's going like this, it starts slow, but then it quickly goes fast. That's growth. All right. So for decay, it's if it starts high and ends low. That's decay. All right. So again, let's give an equation that I think that will help you with this. So let's say we had, I'm just trying to think of one that would be easy for us to understand. Let's say if we said y equals, this is just the formula, a times b to the x, all right? This a right here is your initial value, all right? This b is going to be your growth or your decay rate. Okay, so again, if this number right here, if your b value right here is less than 1, but it's greater than 0, then it's going to represent a decay. So again, this right here is less than 1, but it's still greater than 0, so it's representing a decay. So it's meaning everything's quickly decaying instead of growing. Okay, so I think that will help you, and we'll look at some more examples later, but I think this is enough for us to understand for today.